Welcome back, great minds. Now we are still on log reading, and we have an example, two examples on the board. Maybe one will be solved in another episode, but for this episode, we need to solve the number one. And that number one says, if log to the base 8 of n equals r over 2, log to the base 2 of 2n equals s, and s minus r equals 4. Find n. Okay, let's start here. Solution. From the expressions that are given, this. Now we take the first one, which says log to the base 8 of n equals r over 2. Then from this thing now, from this expression, of course we know from the definition of log reading that n now will be equal to 8 to the power of r over 2. The logarithm of a number is the power to which the base will be raised to give that number. If log of n to the base of 8, if log to the base 8 of n equals this one, that means n equals to 8 to the power of r over 2. Then, therefore, this one log, if this is true, then the second one, which is log to the base 2 of 2n, now, this now will be equal to log to the base 2 of 2, since n equals 8, that is multiplied by 8 to the power of r over 2. And from the second expression, we are told that this, which is log to the base 2 of 2n, this one equals r. But we just expressed this log to the base 2 of 2n in another form, since n equals this one. So that one will be equals to now log to the base 2 of this number here, 2 multiplied by 8 raised to the power r over 2 is equal to s, right? This, and which is equal to log to the base 2 of 2 times 2 raised to the power 3 to the power r over 2 is equal to s. Are we there? And this is log to the base 2 of 2 multiplied by, when you open the bracket now, we have 2 to the power 3r over 2. Bracket close equals what? S. And this is the same thing as log to the base 2 of, these are the products, so we take the addition, and of course we know that this is raised to power 1. Am I right? Yes, I'm right. This is raised to power of 1. So this is the product. From the laws of indices, we add the powers and they have the same base. So this is log to the base 2 of 2 to the power of 1 plus 3r over 2. And the set is equal to what? S. Right? And then we know log of a number to the power is the same thing as the power multiplied by log of that number. So this is the same thing as 1 plus 3r over 2 log to the base 2 of 2. Just took this power. Of course, this has the whole of this power. We brought it forward, which is according to the laws of logarithm. This one, which is equal to what? S. And of course, log of a number to the same base is equal to 1. So we have that 1 plus 3r over 2 is equal to what? S. Right? Now, looking at the third expression says s minus r equals 4. S minus r equals 4. From the third expression, s minus r equals 4. And of course, we've gotten s as this. Therefore, 1 plus 3r over 2 minus r equals what? 4. And now, we have to add these like terms. We have to add these two numbers. So we have 1 plus, so when you're adding this 3r over 2 plus r, of course, the LCM there is what? 2. And then 2 into 1. So now this is 3r. Then 1 minus 1 and 2 is 2. Then 2 times r is minus 2r is equal to what? 4. So we have 1 plus 3r minus 2r is equal to r over 2 is equal to what? 4. Right? And then this is the same thing as r over 2 is equal to 4 minus 1. And this implies that r over 2 is equal to what? 3. And then r equal to multiply 2 times 3. This is equal to r, and r is equal to what? 6. Right? Remember what you are asked to get. You are asked to get n from the question. You are asked to get n. Now, you look back. The first place we did something where we say from this first expression we got that n equals 8 to the power of 2 over 3. Now we have to bring it here because we're looking for n. Therefore, n equals from here, which says 8 equals r over what? 2. And of course, we've gotten what r is. This implies that n equals 8 to the power of 6 over 2. Right? And this is equal to 8 to the power of, this is equal to 8 to the power of 6 divided by 2, 8 to the power of 3. And n is equal to 5, 1, 2.